This is one of a series of videos that I'll be making on revision for the upcoming half-yearly exam for Year 9 Science. In particular, focusing with these particular series of videos on the chemical world topic. So I'll be looking at atoms, elements, and the periodic table in this video. They're supposed to be as concise, as brief as possible. These aren't meant to be lessons, they're meant to be more of a recap based on experience. The types of questions you get really test your fundamental, your most basic level of understanding. And knowing atoms, if you know what atoms are, the parts of an atom, how they work, you can go from there and learn it and know how elements, compounds work, how the periodic table works, and so on and so forth. So let's go back to the idea of an atom. So an atom is interchangeable with the word building block. I want you to think of the word building block. It's the building block of matter. Think of Lego pieces. If I give you a castle that's made of Lego, right, you can take apart the castle and you'll have individual Lego components. Okay, same thing with matter. Matter is stuff. Okay, that's you, me, the tables, the chairs around us, the screen that you're watching, the things that we can't even see for that matter. So the air as well, the invisible air, everything that we see around us and that we can't see for that matter is called matter. Okay, and matter is typically made of atoms. Let's look at one of the most simplest atoms in the universe, helium. Now, I'm not going to do hydrogen because hydrogen doesn't have neutrons. I want to illustrate the different parts of an atom. The acronym I've been teaching you in class, the mnemonic, is PEN. PEN stands for proton, P for proton, E for electron, and N for neutron. These are the three main parts of an atom. So helium looks like this. You've got 2 protons, 2 neutrons, and 2 electrons. Okay, this is a horrible drawing, so excuse the mess, but you get the idea, I'm sure. Protons have a positive charge, P for positive. Electrons have a negative charge, and neutrons are neutral. They've got no charge, 0 charge. So how do we know that helium has 2 protons, 2 neutrons, 2 electrons? Well, on the periodic table, it typically looks like this. So the periodic table, just to recap, is basically a chart of all the known elements in the universe. Elements are pure substances. These are made of only one type of atom. Why is this important? Well, for example, if you're someone who likes jewelry, particularly gold, you better hope that the jewelry you're buying is made of gold atoms, okay, and only gold atoms, okay? Elements, they include oxygen, helium, as I mentioned, gold, copper, okay, the copper that makes up the circuits in your devices, silver, sodium, aluminium, so on and so forth. Okay, there's about 118 chemical elements, okay, and scientists have been able to chart them into groups based on their similarities, similar properties, similar chemical and physical properties. But anyway, so helium on the periodic table, just like any other element, it looks like this. It's got the symbol He for helium. Typically got the atomic number at the top, the chemical symbol, which is He, the atomic mass or the atomic weight below the symbol, 4.002602, and the name of the element below it, helium. Okay, it's in a box. On the periodic table itself, which is basically the HSC periodic table, they give you the HSC periodic table in your exams, in your junior science exams. It literally tells you, gives you a legend, a key, and it tells you that this is the atomic number, that's the chemical symbol, that's the chemical atomic mass or atomic weight, and that's the element name. So it tells you right there, you don't need to memorize anything. I promise, okay, even me, I haven't memorized the periodic table. You don't need to. It's always given in an exam. And I'm sure some of the top chemists in the world haven't even memorized it. So no pressure. So the atomic number at the top, the 2, try and use a different color. It's getting a bit messy. That's the atomic number. The atomic number tells you the number of protons and electrons. Okay, protons or electrons. So helium has an atomic number of 2. It's got 2 protons and 2 electrons. Why does it have the same number of electrons as protons? Well, atoms generally in nature, they're neutral. They've got no charge overall. So the plus 2, the 2 protons and the 2 electrons, minus 2, they balance, they cancel out. Okay, think of a seesaw. I like to think of atoms as seesaws. So plus 1 is plus 2, there's 2 protons. Minus 1 electrons is minus 2, and they cancel out. So 2 protons, 2 electrons, okay? The atomic mass, now here's what you do with the atomic mass. This is the number of protons plus neutrons. Why is it protons and neutrons and not electrons? Well, electrons are so tiny, so small, their mass is almost negligible. It's almost 0, even though it's not 0. They still have mass. But most of the mass from an atom comes from the protons and neutrons. Hence, atomic mass is protons and neutrons. In this case, 4.002602, you either round up or round down. The closest number, whole number, nearest to this number is 4. So 4, and it makes sense, it's correct, because there's 2 protons and 2 neutrons. Okay, 2 plus 2 is 4, that's the atomic mass. So that's helium there. Let's look at another one. Let's suppose I give you sodium, so 11Na 22.99 sodium. This is how it's presented on the periodic table I've given you in class. Okay, you can check it out on Google as well, HSC periodic table. It's presented like this. So the top number, literally just reading it off the periodic table, it tells you on the key, that's the atomic number, the very top number. That's the symbol. That's the atomic mass. And that's the element name, obviously. Always think of this as well. The atomic mass is always bigger than the atomic number, okay, typically. Okay, atomic number, how many, so let's suppose in the exam they ask you how many protons and electrons sodium has. Look at the atomic number. It's 11. 11 protons and 11 electrons. How many protons and neutrons? We look at the atomic mass. Protons plus neutrons. Now this, you have to round it up. 22.99 is about 23. So there's 23 protons and neutrons. Now, how do you work out the number of neutrons? What you do is, you take the bigger number, the atomic mass, minus the atomic number. And I'll show you why. Atomic mass, if you recall, let's give them symbol. So the atomic mass is the protons plus neutrons, P plus N. Let's call it P plus N. Protons plus neutrons. Atomic number is the number of protons or electrons. I'm going to put P in this case for protons. This is simple algebra. P minus P is 0. Left with N. N is the number of neutrons. So that's why atomic mass minus atomic number gives you the number of neutrons, N. Okay, just a bit of algebra. So the number of neutrons in sodium is 23, the atomic mass, minus the atomic number, 11. 23 minus gives you 12. So there's 12 neutrons. You can check your answer. 12 neutrons plus 11 protons is 23. That's the atomic mass, okay? So you can check it. So that's a bit about elements there. So if they ever give you a diagram of, let's say, this, 1, 2, 3, 1, 2, 1. So this is an atom here they give you. My bad, put 4 neutrons here. And they ask you what element this is. Well, let's count the electrons. So the easiest things to do is count the electrons. There's 3 electrons. So you go to your periodic table and you look for the element with the atomic number of 3. And that element is lithium. Okay, 3 electrons. It's also got 3 protons. And there's 4 neutrons. So 4 neutrons plus 3 protons, that gives you 7, atomic mass of 7. Indeed, lithium has an atomic mass of 7. Okay, it's 6.941, but it's about 7. Okay. Also remember, number of shells, number of electrons in the first shell around a nucleus is 2. number of electrons in the second shell. Okay, I'm putting the dashes because I'm a bit lazy here. Let's write the rest, but anyway. 8 electrons in the second shell. In the third shell, 8 electrons too. This is for the first 20 elements, right? They won't ask anything more than 20 in an exam. It can get complicated. So 2 electrons in the first are only allowed, 8 in the second, and 8 in the third. So that's a recap there on atoms, elements, and the periodic table, part 1.